American Physics Olympiad, year 2020. F equal MA. First round. Exam A. This year was split by 2 days, and each student can choose any of these days to participate. As usual, it was given 75 minutes for 25 problems. If you want to get more interesting problems, subscribe for this channel. Problem number 1. A ball is launched straight toward the ground from height h. When it bounces off the ground, it loses half of its kinetic energy. It reaches a maximum height of 2h before falling back to the ground again. What was the initial speed of the ball? Problem number 2. A rigid ball of radius big R is rolling without slipping along the rib of a right angle chute, as shown in the figure. Which of the points of the ball have the maximum speed? Problem number 3. When an axe is swung with the kinetic energy E directly at a piece of wood, the edge of the axe is buried depth big L into the wood. If the axe is swung with kinetic energy 2E, how deep will it be buried into the wood? Assume that the axe is wedge-shaped with a constant angle and that the force per unit contact area between the axe and the wood during the impact is proportional to the depth. Problem number 4. 4 identical rods, each of mass m and the length 2d, are joined together to form a square. The square is then spun around its center, as shown in the figure, at an angular frequency of omega. What is the magnitude of the force that the joints between the rods at the corners of the square must bear? Problem number 5. A pendulum of length L oscillates inside a box. A person picks up the box and gently shakes it horizontally with a frequency omega and a fixed amplitude for a fixed time. The final amplitude can be maximized if omega satisfied next one. Problem number 6. A planet is orbiting a star in a circular orbit of radius r0. Over a long period of time, much greater than the period of the orbit, the star slowly and steadily loses 1% of its mass. Throughout the process, the planet's orbit remains approximately circular. The final orbit radius is closest to which one? Problem number 7. An astronaut standing on the exterior of the International Space Station wants to dispose of 3 pieces of trash. They face the station's direction of travel with the Earth to the left. From the astronaut's perspective, the 3 pieces are thrown first left, second right, and third up. To the astronaut's frustration, some of the pieces of trash return to the space station after several hours. They are next one. Problem number 8. The velocity versus position plot of a particle is shown to the left. Which following choices is the correct acceleration versus position plot of the particle? Problem number 9. A block of mass m is attached to a massless string. The string is passed over a massless pulley and the end of the string is fixed in place. The horizontal part of the string has a length L. Now a small mass m is hung from the horizontal part of the string and the system comes to equilibrium. Diagram not necessarily to scale. Neglecting friction everywhere. The tension at the end of the string is next one. Problem number 10. During this process of problem number 9, the block has been raised by approximately a height of which one? Problem number 11. The maximum tension per area a material can sustain without failure is called its tensile strength. Plain steel has a tensile strength of 415 megapascal. What is the maximum mass one can hang on a vertical steel rod of neglectable mass and a diameter of 2 centimeters? Problem number 12. A point mass M is glued inside a massless hollow rod of length L at an unknown location. When the rod is pivoted at one end, the period of small oscillations is T. When the rod is pivoted at the other end, the period of small oscillations is 2T. How far is the mass from the center? Problem number 13. A ballerina with a moment of inertia I is quickly twirling with angular velocity omega. In her hand she has a pen of mass m at a radius r from her axis of rotation. The ballerina releases the pen. Afterward, what happened to the vertical component of the angular momentum of the system consisting of the ballerina and the pen? You may ignore all friction, but not gravity or normal forces. Problem number 14. Two blocks of mass m are placed on top of each other, and the bottom block is placed on the ground. The ground is frictionless. The static and kinetic coefficients of friction between the two blocks are μs and μk, with μs greater than μk. The blocks are at rest initially. When a constant horizontal force F is then applied to the bottom block, which of the following graphs could show its acceleration as a function of force F? Problem number 15. As shown in the figure, a vessel contains two types of liquid. The liquid with density ρ1 on the top and ρ2 on the bottom. The depth of the top liquid is h1, and the interface area between the top and the bottom liquid is s1. The bottom liquid has a depth of h2. The area of the bottom of the vessel is s2. What is the gauge pressure? Other words, pressure in excess of atmospheric pressure at the bottom of the vessel. Problem number 16. Liquid droplets store a given amount of potential energy per unit surface area due to their surface tension. When two identical, nearly spherical liquid droplets coalesce on a certain type of surface, part of this energy can be converted into upward kinetic energy, causing the coalesced droplet to jump. Assuming the conversion is 100% efficient, how does the maximum height h depend on the radius r of the initial droplets? Problem number 17. Paul and the giant stands outside on a force meter calibrated in newtons, which reads 5000 newton. Paul is wearing a large cowboy hat, which has horizontal cross-sectional area A equal 1 square meter, and completely covers both him and the scale when seen from directly above. At time t equals 0, rain begins to fall vertically downward on pole, and any rain that hits his head is collected in the hat's brim. The raindrops have a constant downward speed of 1 meters per second, and the rain accumulates on the ground at a rate of 1 millimeters per second. What is the reading in newtons on the scale as a function of the time t more than 0 in seconds? The density of water is 1000 kg per cubic meter. Problem number 18. A masslet rigid rod is pivoted at one end and a mass M is at the other end. Originally, the rod rotates frictionlessly about the pivot with a uniform angular velocity such that the mass M has speed v. The rotating rod collides with another mass M at its midpoint, which then sticks to the rod. After the collision, what is the kinetic energy of the system? Problem number 19. A system of cylinders and plates is set up as shown. The cylinders all have radius small r and roll without slipping to the right with angular velocity omega. What is the speed of the top plate? Problem number 20. A car is driving against the wind at a constant speed v0 relative to the ground. The wind direction is always opposite to the car's velocity, but its speed fluctuates about an average speed of v relative to the ground. The air drag force is AV relative square, where A is constant and V relative is the relative speed between the car and the wind. What is the average rate P of energy dissipation due to the air resistance? Problem number 21. A circular table has radius r and n greater than 2 equally spaced legs of length h attached to its perimeter. Suppose the table has a uniform mass density with a total mass m and neglect the mass of the legs. Assuming the table does not slip, the minimum horizontal force needed to tip over the table is next one. Problem number 22. A collision occurs between two masses. In each internal reference frame, one can compute the change in total momentum, delta P, and the change in total kinetic energy, delta K, due to the collision. Which of the following is true? Problem number 23. Steve determines the spring constant K of a spring by applying a force F to it and measuring the change in the length dx. The tools he uses to measure F and dx both have a constant absolute uncertainty, leading to an uncertainty in K of delta Ks. If Tiffany measures the same spring constant with the same tools, but by using a force that is 5 times larger, what will her uncertainty in K be in terms of delta Ks? Problem number 24. A mass M is connected to one end of a zero length spring with a spring constant K. The other end of the spring is connected to a frictionless bearing mounted around a horizontal pole, so that the mass can swing in a vertical cycle of radius r around the pole. The setup is shown in the figure below. What is the vertical distance h between the center of the circular orbit and the axis of the pole. Assume that both the diameter of the pole and the rest length of the spring are negligible compared to r. Problem number 25. A ball of a negligible radius and mass m is connected to two ideal springs. Each spring has a rest length L0. The springs are connected to the ball inside a box of height 2L0, and the ball is allowed to come to equilibrium, as shown. Under what condition is this equilibrium point stable with respect to small horizontal displacements?